Welcome to my another knowledge sharing video where I will be taking you through the journey of automation of infrastructure service deployment process. I have made this video so that I can give you some insight into how we can simplify our cloud infrastructure creation and management process by using general purpose programming languages that we are already using to write our business applications. That is very important because that allow us to treat our infrastructure as we treat our application code and follow the same practices such as version control, code review, test driven development, commit frequently, etc. This is not a new concept. Infrastructure as a code has been in DevOps practice from quite some time. However, it is mostly using tools that are based on DSL or domain specific languages, such as Terraform, which is kind of limiting to defining your infrastructure code declaratively. Well, there is nothing wrong with Terraform or in declarative style, but I think it doesn't bring the infrastructure close to the development process because of two very important factors. Person has to learn tool specific DSL or domain specific language. And the second one is it doesn't organically fits into lots of development processes such as code review, test harness, etc. Also, while you automating your infrastructure, there is a need for low level control versus high level configuration. What I mean is that in some cases, you want to control infrastructure by providing low level details such as security groups, a routing table, or even CIDR configuration for your VPC or subnet. Where in other cases, you wanted to use a cloud provider's managed services such as Lambda, API Gateway, by just providing code for your business services. Now, in this video, I will be demonstrating to you how to automate the management of a cloud infrastructure as well as business service deployment that will be used as a foundation to run our production grade application on the cloud. Most importantly, by using the configuration style and programming languages that you know and already using building your business applications. Now, this is not just another demo, this end-to-end demo using a multi-component app and deploying on real-world cloud infrastructure by utilizing many customs and managed services using couple of frameworks, serverless and Pulumi, which is provides simplicity and natural adoption of the framework while keeping the general purpose programming language and configuration over DSL or domain specific language. The serverless framework, which is the first one we are going to use, uh, that provides YML based configuration for deploying apps and next generation infrastructure on the cloud. Where Pulumi, which is our second framework for automating our infrastructure, is an open source library that lets you use a general purpose programming languages like TypeScript or JavaScript or Python, etc., to build your infrastructure on your cloud providers of choice. Now, let me go through the sample app which we will be using to demonstrate infrastructure as a code throughout this video. So let's go through the sample app. Now, this is a very simple app which basically allow users to vote for their favorite song. But there are few components which is used to build this whole app. The first one is that we are going to deploy this app as on the live domain, so you can understand all the building blocks around how to actually host a particular app. Also, we are actually using the static and JavaScript to build this interface for the app. There are a couple of functionality where user can see the number of current votes for a particular song. But if they wanted to cast a vote or add a vote, they have to log in. And for that, we are using auth0 as an external identity authentication provider. So you can click on login button. I already have an account, so I can actually use my existing account. I can log in, and then I can actually see the box or the functionality which allow me to select a song and basically cast a vote. And you can see that I can actually cast my vote for a particular song. Um, and as the end of the functionality, you can just log out. You can still see the votes, but of course you cannot cast the vote. So there are a couple of components which basically allow you to publicly access some of the functionality and ask you to be login and use the protected functionality after login. So this is the sample app which we are going to use. Now, let's talk about the deployment architecture for our app so that we can understand different building blocks, which we will be using to while building this whole infrastructure. We have divided our deployment infrastructure into three categories, and we call it hosting automation, web application automation, and backend service automation. For hosting automation, we will be using Route 53 to host our website. We will be talking to certificate authority to acquire SSL certificates and configuring a CDN or CloudFront for actually getting the CDN functionality. Then we will be having the load balancer, application load balancer, which we'll be using with our custom VPC who's hosting two subnets in two different zones and running our web servers for providing the high availability. We're also going to configure the NAT gateway to actually talk to outside services such as GitHub for getting the static file for our website, as well as Auth0 to provide the authentication and authorization functionality. Our web server will also be talking to our business services, which we will be hosting on Lambda functions, and that communication will be through API gateway. So we will be configuring HTTP endpoints for getting the songs detail as well as votes, and also adding the votes after user logged in. We will be having two business Lambda functions, which is basically getting the list of songs as well as adding the vote to a particular song. And also we will be configuring a Lambda authorizer, which will be validating the request for the protected endpoint. And everything will be persist into DynamoDB. So these three parts actually using a different deployment configuration or framework. The backend service automation, we will be using serverless framework, which is basically provides us to configure our lambdas and API gateway configuration using YML. And the reason for doing that or using serverless, because we wanted to concentrate on the business logic, developing the business services instead of actually getting a lot of control around the configuration. Because we are going to use AWS managed services for the API gateway and for hosting the Lambda and as well as the DynamoDB. So we don't really need to have a lot of control configuring those services, but to just provide our business logics to host on those services. While for web application automation, we are going to use Pulumi, which basically provides us to write the whole infrastructure automation using the programming languages, and we are going to use TypeScript in our use case, and automating the whole infrastructure components, like for example creating the custom VPC, adding subnets, creating routing tables, security groups, etc. While for hosting the automation, also we are going to use Pulumi because we wanted to have the control around how do we get the certificate, which particular reason we need to acquire the certificates, and also some other low-level details around configuring CloudFront and Route 53. Right. So as I mentioned in our deployment architecture, we will be dividing this whole process into three deployment, and we will be starting from the backend process or the backend service automation by using serverless, and then we will be moving on web application automation, and then finally we will be completing with the hosting automation. So on that note, let's get started with our first deployment, which is our backend service deployment. For our backend service automation, we will be using serverless to deploy API endpoints, Lambda functions, and DynamoDB. I have added a link in the description which allow you to follow the step-by-step instruction to install serverless CLI. I already have serverless CLI installed. So the next thing what we can do is basically get the code from the Git repo. The link for the Git repo is also added into the description. So basically, we can just clone the repository, and that will give us all the deployment code for all three different deployments. Yeah, got the folder. And we are going to work inside the API Lambda DB folder. Now there is another one more prerequisite before we actually start deploying our API and Lambda functions on AWS. It's to actually set up a Auth0 account. So as I mentioned before, Auth0 we will be using as an external identity provider for authentication and authorization. Again, I will very quickly show you what we are going to need from Auth0, but I'm not going to go through the whole setup. You can actually follow that in your own time. So basically in Auth0, you need two things. You need to set up the application. Of course, before doing that, you have to log in and you have to register yourself. But after that, you have to set up the application. So, for example, in my case, I have set up this whole application. And most important thing is that you should be, if you're testing locally, you should be allowing or configuring your local host. Otherwise, whatever the domain you're going to deploy this app, that has to be configured. Otherwise, it's not going to work. For this deployment, we need the API. So there is another step which we need to configure. This is basically to protect our API. So we will be configuring a particular API settings here and providing some information which we are going to use while we actually deploying it. So the most important thing, we are going to use the identifier. So please configure your own identifier. Don't try to copy this because I'm going to change this after I complete the recording or deactivate deactivating the whole account. So we need this identifier for us to proceed with the deployment. And the second thing we need is basically the public key to access this account. So that you can actually, if you go to your account settings and if you go to the signing key, you will have the currently used key, and you can just click on those dots and download the signing certificate. That's all we need to carry on with our deployment. So I already have a public key saved in my local system. So I'm just going to copy that key into API Lambda DB folder. And then I'm just going to go through and see what I have in this folder. So you can see that I got the public key, which I copied from my local folder. I've got the serverless.yml, which we are going to use to configure all the workflow to deploy our components. I also got the secret, which I have to replace with the identifier getting from the Auth0 account. And then I got package.json, which basically going to install some JavaScript libraries. And then I got three Lambda functions. So add vote, auth, which for the authorization, and list vote. So let me quickly change the secret first before we actually start deploying our infrastructure. So if I go to the secret, this is where you need to actually get your identifier from the auth0 and replace it. So let me go through that. And if I go to the APIs again and click on the API which I've created, I can copy the identifier from here, come back to my folder file and replace it. Now we are all set to start the deployment. But before we actually do the deployment, I would like to just go through the serverless.yml, which is the main file, so that you can understand what we're supposed to be doing during the deployment. So as you can see, this is a YML configuration style. Um, there are some metadata mentioned about the deployment, so you can actually have multiple deployments based on the stage and services and things like that. This is totally up to you how you actually configure this. From here, it start with defining the provider. So you can actually, right now for us, it's AWS, and also the runtime for the lambdas we are going to use, which is Node.js. Um, reasons where we're going to actually deploy the lambdas, and then some environment variables for defining the table name, and as I mentioned about the public key and secret, which our authorizer lambda function is going to use to validate the JWT token for add vote lambda function. Then we also creating a IAM role, which is basically allowing our lambda functions to have the access to the DynamoDB table. And here we are actually configuring three lambda functions. So the authorizer, the get songs vote counts, and the record songs vote. Now, the difference here is that authorizer, we are not exposing this as API endpoint, right? This is the utility function which will be used by other lambda function who wants it to validate the JWT token. The second function, which is get vote count, this is basically the publicly available API. So this does not really require any kind of login or JWT token. However, for the record songs vote API, we are configuring auth as an authorizer, which means this is protected API endpoint, and the application or a user who accessing this endpoint has to have a valid JWT token associated with the request. And then we finally creating the resource, which is basically the our DynamoDB table. So we define the attribute, key schema, and all those kind of different things. And then we are also configuring some of the response errors for authorizer failures scenarios, right? So this is all 74 line of code, which is basically going to deploy two API endpoints, three Lambda functions, one DynamoDB table, and also associating IAM role and some other configuration related to that. So on that note, we can actually start the deployment process. I mean, you can actually have a look all those Lambda function, but these are just pure JavaScript Lambda function, which is basically adding the vote um, into the DynamoDB table and also getting the vote from the DynamoDB table, right? And yeah, so let's move on and start deploying our uh, first set of components, right? So we are in API Lambda DB folder. The first thing we need to do is we need to install some JavaScript dependency using npm install. Uh, that will actually install all the dependency used by our Lambda functions, like for example, validating the JWT token and other JavaScript libraries. And let me just clear this thing. Now we should have the node module created with all the dependency. And now we are actually ready to run the serverless command, which will start deploying things on our AWS account. So for to do that, we can just directly type serverless deploy, and that will take few couple of minutes, I would say, to actually complete the overall process. Now you can ignore this warning for the time being because I have developed this demo using the not the latest version, but when I actually updated the latest version, it actually started giving this warning, which I can fix in future. But for the timing, it's not actually impacting anything. So as I said, it's going to take some time. So I'm going to speed up this process. Okay, so the deployment has been finished, and there are few things which is basically configured for us. So as you can see, all the service and state, this is internal to us, how we actually managing this whole deployment. We know the reason, which is EU West 2 application stack and the number of resources created for us. Now, the most important thing what we can actually use from this deployment output is the URLs or the API endpoints, which we configured for our two APIs, right? So we can actually directly use this, copy these URLs, yeah, and use a tool like Postman, for example, uh, to test those URLs. So if you test the votes URL, which is basically getting the votes for us, we should actually have the empty array because we haven't actually added any votes so far, right? So let's do and test the add vote functionality. Now remember, this add vote functionality required a valid JWT token, right? So let me first configure this post thing and also the body. Now for getting the JWT token, we need a valid JWT token, and to get the valid JWT token, we can again go back to the API details, and if you click on the test in your account, you will see this script which you can directly copy and again come to the console and run that script, which actually going to give you the valid JWT token which you can actually use for testing. So if I go back to the Postman and replace my old JWT token with the new one, and if I send this, I should get vote a counter increment to 1. Now I can actually submit few times and see if that works. And then if I go back to the get API, I should actually get the latest vote count for that particular song. So this seems to be working. We can also go into our or log in into our AWS account, and we can see whether all those Lambda functions are created. So we can see that 3 Lambda functions are created, and as well as we can go back and see the API gateway, or let's say let's check the DynamoDB first um, table, and you can see the song tables is also created, and then finally we can go to the API gateway and we can see the API resources, and all both the methods are actually created here. So the post method and the get method for both the endpoints. So this seems to be working fine. Before we actually move into the next deployment, you need to copy this particular ID, which is basically the unique identifier for our APIs or our API endpoint, because we need this IP to be configured, or sorry, this ID to be configured in the next deployment, where our web server is going to make the request to this URL. So we need to provide this as an environment variable. So keep that handy when we actually move to the second deployment. Now, if you wanted to, take a break here and you don't want to keep running those Lambda functions and API gateways and DynamoDB table, then you can simply destroy all the things, or remove all the deployment components by just running the command serverless remove. and that will basically remove whatever resources we have deployed as part of this particular script, and you can start this from scratch again. But again, remember, when we actually moving to the second deployment, we need to have this particular id handy so that we can set our environment variable. Right. So as you can see, this whole deployment artifacts or resources has now been removed. And before you start the next deployment, you need to rerun the whole process to create those resources. Right. For the second deployment, where we going to deploy web application, and also which is going to run on the web servers, on EC2 instances and subnets and VPCs and all those kind of things, we are going to use framework or the tool called Pulumi, right? So as always, the link for setting up Pulumi or installing the CLI will be in the description. I already have installed tool. Um, this is the latest version which I have installed. When you actually installing, you might actually have the different version by the time. So we are in a different directory now, in different folder now, which is network apps LB. So basically, we are setting up the whole network infrastructure by using the VPC and public subnets, and also using EC2 instances, creating EC2 instances to install our web servers, as well as the load balancer, application load balancer, to access those web servers, right? So let's get started. The first thing we need to do is to actually install all the dependencies or JavaScript dependencies required by the Pulumi tool itself for that particular deployment. So I will go through the file structure in a bit. So let's just first install all the dependency required. Right, so this is all done. Once it's finished, we also need to set a few environment variable for our deployment to work, right? So I'm going to go through each one of those environment variables and also explain how you're going to get the values in your environment, right? So the first thing, the first environment variable we are going to set up, which is basically the region, and the region is EU West 2. For me, it might be different for you, but keep in mind that all whatever we have done so far in the previous deployment and what we are doing here should be in the same region. It's not mandatory, but it makes more sense to actually have everything in the same region, just for the simplicity perspective. So we can configure this one. Um, the next environment variable which we are going to configure is basically to allow our web servers to have the access, or our static website to have the access to our auth0 domain. Now, this particular value, you can get it from, if you go back to your auth0 account, and if you click on the applications, and then the application which you have created, this is the value, this is the domain value which you have to actually set in as part of this particular environment variable. The third environment variable will be to set up the client ID. Now, the client, for the client ID also, you will actually go to the same page, and you can actually see this value in the against the client ID, and you can use this one for that particular environment variable. Now, the fourth one is basically to set up audience. Now, this is the same audience or identifier we used in the previous deployment. So this is exactly the same value you have to set up. And the final one is basically, as I mentioned in the last deployment, your API endpoint ID, right? So hope you have saved that ID somewhere, which you need to use here to configure the API gateway as part of the environment variable. So once we set up these 5 environment variables, we are ready to run Pulumi tool to start deploying or creating VPCs and subnets and everything. But before that, let me just go through the code so that you can understand what what this tool is actually going to do as part of this particular deployment. So when we get into this tool, the most important file here is index.ts, sorry. And this is where you will actually write all your TypeScript code uh, to run through the whole infrastructure workflow. Now I'm using TypeScript, but Pulumi is also supporting JavaScript, Python, and other languages as well. So you can actually use those kind of libraries, including some of the libraries which will allow us to call all those different functions to create the infrastructure. Um, and here we are actually getting some environment variables which we have set up just before this particular step. And then for in the first creation step, we are actually creating the VPC by defining the CIDR block, as well as in it saying that we need this VPC to support two availability zones, and also create subnet on those two availability zones. On those subnets should be public subnets. So we are not interested in the private subnet for this particular deployment. Once we done this, we are also configuring some security group specifically to the port 80 and port 22, so that we can actually have the access using SSH, and also allowing all the outbound traffic for all the different ports. Once we've done the security configuration or security group configuration, then we actually started defining the configuration for the EC2 instances. So of course, we're defining the size and the AMI for, this is basically the AMI for the Linux, Amazon-based Linux operating system, and also some startup script. So basically, when we initializing EC2 instance, we also wanted to get our code or static website code from the GitHub, deploy it, run some replacement with the API, sorry, with the IDs and other things, and also starting up a simple Python web server so that we can access that those static components. And here we are actually creating two EC2 instances, to one each one of them deployed on the different availability zone by using the subnet IDs. And then finally, we are defining, or we are creating the application load balancer by defining the egress rule, and also adding those two EC2 instances as part of the target of that particular application load balancer. So this is all we are actually doing as part of this particular deployment. So let's go and run this deployment. By doing that, let me clear the screen. For running the deployment, you just need to write pulumi up command, and that will basically show you the preview first. So that's really handy, because then you can see what is actually being will be created part of this particular deployment. So you can see that the VPC is creating, the subnet will be created, security groups, application load balancer, and all those things will be configured. So once you're happy with that, you can just say yes, and then the actual deployment will start. Now, this deployment will take few minutes, at least 2-3 minutes, just because we are also deploying or creating the application load balancer, which will take time. So I will pause that here, and once it's complete, I can come back. As you can see, the deployment is now completed, and we can see the 43 resources has been created as part of this particular deployment. There are a couple of values we need to save for the next deployment, and one of them is the ALB, or the application load balancer ID. So you need to keep this value so that we can actually use this in the next or the final deployment as an environment variable. And the second one is the endpoint. You can use endpoint or AR, and any of them. Both values are exactly same. This is also we need for the final step of the deployment. Now we can test this deployment by using the endpoint URL, which is basically the application load balancer endpoint URL. And we can just go back to our browser and access this URL. and you should be able to see the website loading or the app loading. But you can't really see anything else, especially this login button is actually deactivated. And the reason for that, there are two the reason. First of all, if you remember, when we created our account on auth 0, we also configure allowed URLs, callback URLs, right? And here you can see we haven't actually configured the URL which we're currently using, our load balancer URLs. That's one of the thing. The second thing is that auth 0 only allowed integration from the HTTPS URLs, not the plain HTTP URLs. And AWS application load balancer does not give you the HTTPS URL. That's the limitations. But we will fix that problem in our final deployment, where we're going to use the SSL certificates. Also, we're going to configure our domain as well as the CDN using the CloudFront. So we are going to create the whole app using the HTTPS URL. Then you will be able to access all of the functionality in that app. However, if you again want to pause here and come back later for the final step, you don't want to keep running those resources on AWS account. So you can just run Pulumi destroy, and that will again give you the preview that what are the resources it's going to delete. And if you're happy with that, then you can just click as or sorry, select yes, and that will delete all the resources. But when you actually come back to the final step, you have to rerun this deployment to have all the resources in place. For the final step in our deployment process, we are going to create a Route 53, which will basically have the access to our live domain. We are also going to get the SSL certificates and also configuring CloudFront to provide the content delivery functionality to our website. So let's get going. We will be working in a different folder now, which is basically the DNS SSL CDN folder. So the first thing we'll do, we'll deploy all the npm dependency or the JavaScript dependency, which is needed by the Pulumi tool itself. So we're just going to run npm install, and this is all done. The second step in this deployment is to set few more environment variable, which will be used by this particular deployment. So the first deployment variable is the reason, which we are going to set. In my case, it will be EU West 2, because all of my services are running in the same region. The second one is the hosting website. So this is my website URL, uh, which I'm going to configure as part of this environment variable. This value will be different for your website. And if you don't want to deploy that, then of course you cannot carry on with this particular step, and you have to just test locally your first and second deployment. The third environment variable will be the ARN for the application load balancer, which we got it from the previous deployment. In my case, this is the ARN value for my application load balancer. And we are also going to configure the final environment variable by providing the load balancer URL itself. So these are the four environment variables which needed by this particular deployment. And now, before we start the deployment, let's just go through the code and see what this deployment is actually doing. So again, in this folder, we have the index.ts file, which is basically having all the code for related to this particular deployment. So we are configuring environment variables here so that we can access locally. We also doing creating the S3 bucket for CDN logs or request logs. There are some other configuration going on, but here we are actually creating the certificates or acquiring the certificate, SSL certificate, which we will configure with our DNS. So this is all part of this is where we are actually creating the cloud front. And once we create the cloud front, here in this particular function, we are actually adding that cloud front as part of the Route 53, and also creating the alias record for our website. And that's it. And finally, once the deployment is complete, we will actually get the URL. So let's just run this deployment. For running this deployment, again, we can just run pulumi up command, and that will give you the preview first. The resources is going to create as part of this deployment. And once you are happy, you can actually go ahead and start the deployment, the actual deployment. So here you can see it's actually going to create certificate Route 53 record, DNS, and CloudFront, and other configuration. So let's just go and start the deployment. Now this is going to take a little bit more time compared to the previous deployment, because as you can see, the whole record, the Route 53 configuration and DNS records and all those kind of things will take time to replicate into different servers. So it is going to take time. So I will pause this now, and will come back once the deployment is completed. So the deployment has been completed, and we can see that the domain endpoint has now been created and configured. So we can just test this to see our app working. And yes, so you can see that the login button is now activated, so we can actually test the complete functionality. So I can log in with my existing account, and you should be able to see the list of songs which I can vote for. Yeah, so it's working, and I can just log out. I can still see the votes displayed, but I can't really vote any further. So this is basically the overall testing for our app. So now we have actually completed all three deployments, starting from the backend service automation to the web application automation and to the hosting automation. So this is it for this demo. Hope that provides you some insights about the serverless and Pulumi tool, and also help you to see infrastructure code as a first-class citizen in your development process. So thank you for watching. Have a nice day.